Another problem in discrete random variable probability distribution. So this is what happened in the table. We do a statistical experiment. The result, there are 9 different results: -8, -5, -2, 0, 1, 3, 5, 7, 10. Okay, so we have 9 different results, and each result has its own probability. So simply speaking, you take an action. The X is one of the results. So every time you take an action, you get a result. Each result has its own probability. So the probability that you will get a 0 is 0.14. The probability that you will get a 7 is 0.18, so on and so forth. So A is find the probability that X is at least 3. So probability, so this is P, that X is at least 3, so that is greater than or equal to 3. So you have to take 3, 5, 7, and 10. Then the probability is 0.05 plus 0.26 plus 0.18 plus 0.09. So that is the question to A, the answers to A. And then B, we have probability at most -2. So X is less than or equal to -2. So you have to take -2, -5, and -8. The probability is 0.12 plus 0.03 plus 0.10. And then C is less than 0.5. Probability X is less than 0.5. There is no 0.5 anywhere in the X, right? But 0.5 is around right here. So any number less than 0.5, yep, we have 0, -2, -5, -8. So the probability is equals to 0.14 plus 0.12 plus 0.03 and then plus 0.10. So that is C. And then D is greater than 3.9. So X greater than 3.9. 3.9 is right there. So we have 5 greater than 3.9, 7 greater than 3.9, and 10 greater than 3.9. There is no 3.9 in the table because every time you do this experiment, it is impossible to get 3.9. So that is 0.26, 0.18, 0.09. So that is the answer to D. And then E and F, we have one inclusive and one exclusive. So E is probability, -2 less than or equal to X less than or equal to 5, including those two numbers. So you have -2 all the way to 5. Then you have 5 probabilities to add. Then that is 0.12 plus 0.14 plus 0.03 plus 0.05 and then plus 0.26. And then the next one is F, exclusive. Exclusive means you omit the -2 and 5. So this time you only take 0, 1, and 3. So the difference is you exclude 2 probabilities. You take 0.14, 0.03, and 0.05. So that is part F. Is the inclusive exclusive important? The answer is yes. The inclusive exclusive is important. Why? Because X is a discrete random variable. I use RV for short. All right, so part F, and then we have part G. Part G is probability that X is no more than 1. So the opposite of more than is less than or equal to 1. So we can't see the table anymore. So I'm going to paste the table over here quickly. So paste the table so I can use my table. So greater than or equal to 1, let's take away the equal. Greater than or equal to 1, so we have 1, 3, 5, 7, and 10. Then there are 5 probabilities to add. So 03, 5, 26, 18, and 9. So that is greater than or equal to 1. And then we have I, GO. The G we have more than 1, and then H we have less than 2. So H we have less than 2. So let G and then H correct that. So this one is H probability x is less than 2. So less than 2, we don't have 2. 2 is right there. So that means we are taking 1, 0, -2, -5, and -8 because they are less than 2. And then we add those probabilities. 0.03, 14, 12, 03, and 10. There you go. And then for the rest of the problems, I would like to find the expected value, variance, and standard deviation of x. So for your convenience, I already gave you the answer. What I am looking for is I want you to write a full expression. So the expected value is 3. The variance is 27. And then the standard deviation. The standard deviation I said is 5, so that is probably a mistake. So the standard deviation is basically the square root of 27. I probably typed a mistake at the beginning of this video, but it's fine. We are focusing on how to get that number. So we want to get credits for writing a full expression. So expected value of random variable, just like the mean, but you don't add all the numbers and then divide it by the sample size. For random variable, you have to find the sum. That means sum of x times its probability. So that means using the table right here. I'm going to paste the table one more time. So this one will be -8 times 0.10 plus -5 times 0.03 plus -2 times 0.12 plus 0 times 0.14 plus 1 times 0.03 plus 5 times 0.26 plus 7 times 0.18 and then plus 10 times 0.09. So that's how you get to the probability. I did the math in advance, so if I didn't make any typo, the answer is equals to 3. But I am not really interested in what the answer is because everybody can do this basic computation, right? What I am interested is I want you to write a full expression. So that tells me you understand how to calculate the expected value of a discrete random variable. We are not really interested in the computation. The computation is so basic. Anybody with a calculator can do it. And then J is the variance. So the variance, we have the sum of each x, subtract the expected value, square the result because we want to avoid negative, and then times probability. So that is equals to the first x minus the expected value, square the result, times the probability. And then we do this for every single x and change the number accordingly. -3 square times probability, -2 minus 3 square times probability, and then 0 minus 3 square times probability, and then 3 minus 3 square times probability, and then 5 minus 3 square times probability, and then 7 minus 3 square times probability, and then 10 minus 3 square times probability. So that according to what I typed, I said that is equals to 27. And then the standard deviation is easy. The last part is K. The standard deviation is just the square root of the variance. Always, when you find the standard deviation, just take the square root of variance. So that gives you an approximation, right? I will leave the approximation to you. So that will be all for this problem. I will see you all in the next one.